welcome to another episode of Math Made Almost Bearable. In this one, we're going to try to show you how President Garfield, or future President Garfield, wove together four relatively simple facts into the beautiful proof of the Pythagorean theorem, which he then published. Well, remember what the Pythagorean theorem says. If you got a right triangle, and it's got sides A, B, and we didn't talk about this one last time, C, this C being the long side, the hypotenuse, then it turns out that C squared equals A squared plus B squared. Now, of course, this is a famous, famous theorem, and there are many, many proofs. Over 300 proofs been published of this theorem. One of them is President Garfield's. All right. So let's see how he did it. This is what he's trying to prove. Well, this is his idea. He says, here's this triangle that I'm given. So that means somebody tells me A, B, C, and I make the triangle. And he says, let's lay the triangle down sort of next to itself, but in the opposite sort of orientation, so that the B is here and maybe the A is here, okay? So I'm making a copy of the triangle along this straight line. So this is a straight line, okay? Let's label all the edges. A, B, C, oh, C's bad, but I hope you won't be confused by that, and E. That means point C, not the C that's up here. This is a little c. All right, and then he says, let's just connect A and E, okay? And now he's made an area. One part of the area is the original triangle. Then there's another copy of the original triangle. Then there's this other weird thing in here. So he can think of this area as either these three triangles or the whole thing. And those two would be the same. Now notice, this is a right angle here, and this is a right angle here. So by a pretty well-known theorem in geometry, these two sides over here are actually parallel. So what are we actually looking at here? I realize the picture's a little complex, but we're actually looking at a trapezoid. Here are the parallel sides, and here's the distance between the parallel sides. So what's the area of that trapezoid? Remember the formula? Look at fact, we'll go backwards. Look at fact 4. The area of the trapezoid is the distance between the parallel sides. Notice that's A plus B times the average of the parallel sides. Oh, but look at who the parallel sides are. A and B. So we get another A plus B over 2. Now, what is that? Notice I'm going to write it way up here. That area, and again, this A has nothing to do with area, okay, so try to forget that. So this is A plus B squared over 2. That's one way to think of that area. All right, now let's look at our copy of the triangle over. This is supposed to be the same triangle as this one. So that means the side opposite A ought to be alpha, and the side opposite B ought to be beta. And in fact, it is. Now tell me, what's that angle in there? Well, look at fact 1. Alpha plus beta equals 90, right? Now what can you say, but let's give this thing a name in honor of these Greeks, we'll call it gamma. What can we say about alpha plus beta plus gamma? Well, they just are halfway around a circle, right? That's just 1/2 of a rotation. So that's 180 degrees. But we know that alpha plus beta is 90, so 90 plus gamma is 180. So gamma turns out to be 90 degrees. Ho-hum, who cares? Let's put the 90 in there. Except, what does that mean about this triangle in here? It's a right triangle. So we got right triangle, right triangle, right triangle. So now let's think of that area in a new way. So this same big area up here is this area, this triangle, this area, this triangle, this area, this triangle. But notice that this one is just a 1/2 AB. And now here's the important part. What's the area of this guy in here? Well, notice that the legs of this triangle, because that's 90 degrees, are C and C. So this has area 1/2 C squared. And this one, of course, is another 1/2 AB. You with me? Good. All right. Now I can actually erase Garfield's picture, because I've got these two expressions that I need to equate. I got this expression by saying it was a trapezoid. I got this expression by saying, no, it's 3 right triangles. All right. But since they both express the same area, they must be equal. So I get a plus b over 2, a plus b squared, equals 1/2 AB plus 1/2 C squared plus 1/2 AB. Well, that's way too many 1/2s for any person. So let's multiply through by 2 and kill all the fractions. So we get a plus b squared equals AB plus C squared plus AB. Well, I haven't used fact 3 yet. What's a plus b quantity squared according to fact 3? A squared plus 2ab plus b squared. And on the other side, if you got one ab and another ab, I guess you got 2 of them. So that's 2ab plus c squared. Now all you got to do is get rid of those 2 ab's, and you got a squared plus b squared equals c squared. Isn't that beautiful? And that was done by a politician. Okay, see you next time on Math Made Almost Bearable.